So, yeah, following on after those excellent technical presentations, I fear I might be dumbing things down a little here, but maybe a better perspective is just stepping back a little bit and taking a bit of a wider view. But I think everyone in the room here would have generated or used water quality data in their careers, and certainly knows the value of the information when you actually, knows the importance of it when you need it. And I guess as budgets continue to get squeezed, we also know the importance of investing wisely those limited funds that we have for monitoring programs. So in this presentation, Rob and I just want to firstly make you aware of the water quality metadata guidelines and go through a bit of what it covers, and also take this opportunity to emphasise the value of implementing these guidelines in your programs. So we'll look at how the guideline can ensure that data has value beyond its sort of initial purpose, and why we're talking about a national approach here and what benefit that can bring. So data really are the lifeblood of a lot of what we do. We generate data because it's essential to achieving the monitoring objectives of things like maintaining our safe and secure water supplies and managing water resources for multiple purposes. There's also billions of dollars worth of decisions made around water and to do with water nationally each year, and even small improvements in the quality of the water information can really reduce risk and save millions of dollars. But when we go to use data, how often are we finding that we don't often have enough information about the data and its context to really be able to use it confidently? And what are the risks of using data when we don't know, for instance, the original monitoring program under which it was generated, or the methods and constraints that apply to it? In the case of data and data management, the practices of our past and present really affect the future. And every time we take observations and make measurements and archive information, we really have that opportunity to create enduring data. And good metadata is the key to that. So I think it's pretty self-evident that water information and water quality information in particular truly is a really high value resource. It's often very expensive to generate in terms of equipment and expertise and time. And one of the notable aspects of the value of water information is that you just can't create it when you need it. You often need to have been investing in it over time to have it when you need it. You can't go out and just buy 30 years of groundwater salinity records or stream pathogen records off the shelf. It's also evident that water information is not a consumable. It's not used once and discarded. Provided you have a minimum set of metadata with that information, its value actually grows over time. And I like to think that some of the most important customers of our information actually haven't been born yet. And its value is not finite. It's not diminished through sharing. In fact, it's quite the opposite. Sharing often increases the value of data. So you have secondary and tertiary users of data, you can multiply its value again and again. So for water quality data, all this depends on having really sufficient and consistent metadata about things like your sample handling, analytical methods, and the conditions at the time of monitoring. So with that, I'll hand across to Rob to talk a bit more about the water quality metadata guideline and what it covers. Thanks, Rob.
All right, thanks very much. Well, my role went back to around about 2010 when the Bureau put out some projects looking at the water information management and improvement, and I think probably a few of you probably got projects in that. Well, I did. And basically the first part of the project was looking at the water quality metadata because it was a burning issue with me, trying to do some water quality analysis and just trying to get information from different parts of the society that's out there collecting water quality data and trying to make some sense of it. So we had a bit of a burn. We decided that we'd try just looking introspectively in Queensland at what's going on in there, and found out that it was a bit of a mess. We put together some information, and then we started going around, and then the Bureau decided that what we'd done, they wanted to do at a national level, so we started going around the jurisdictions, asking them exactly what it is they're collecting, how they're collecting it, putting together some information, and found that there were some huge gaps in the understanding of what the water quality they were sitting in their databases, where it came from, how it was taken, what use of it is in the future. And so that was pretty eye-opening. So we sat back and used all that information and come up with a report looking at what data and what metadata should be kept. It was very extensive, and over the period of the next little bit in the actual production of the guidelines from that information, it was reduced considerably to make it a little bit more pragmatic. So I think, what does the guideline cover? Well, basically, I forgot to mention the AWA's input into the production of these guidelines. We use them as a vehicle of getting out to industry when we did our consultation. So some of you may have seen these guidelines in their original drafts, and some may not, but I think we ended up with about 800 or something hits, and I think about 70 responses to the guideline for consultation. So it was pretty widespread. So what does it cover? Well, we cover right from the sampling, from the actual sample that's taken, right through to the quality of the information. So the sampling context, we're looking at how the sample was taken, where the sample was taken, proper geospatial information about its source, the transport of that sample, the holding of that sample, all these things which are important when you're having a look at the final data to understand that the use you can use that data for. We also looked at putting information in about the program, why the samples were taken, what was the original purpose, is that original purpose able to transport it into the purpose that you might want to look at the data in future times. The methodology, again, more probably in my area, in the laboratory work, what methods we use to actually to create that data, because it's very important. A lot of people say total nitrogen is total nitrogen. Well, I can tell you right now, depending on the method that you use to measure total nitrogen, you'll get different values and different results for different samples in different conditions. Particularly, for instance, total nitrogen a lot of times measured by Kjeldahl digestion or by persulfate digestion. We know from our work that using persulfate digestion, when you get above 50 milligrams per litre of sediment in your water, you get a large reduction in recovery of total nitrogen. And that's very important for us because we're doing the event monitoring samples for the Great Barrier Reef, so there's a lot of money in our samples. And then the quality information, it's about then being able to, as a water quality expert, sit back, look at the data and be able to make an assessment of whether that data is actually of a high enough quality to use for the purpose you're looking at. Obviously, if you're just looking for trends, you may be able to deal with data at a much lower quality than you are that if you're actually trying to produce guidelines and want a bit more rigour, or even if you're doing stuff that you're going to have to stand up in court and put your hand on your heart and say that that's the facts. So there's going to be a different level of quality required for each of those purposes. And what we've done is we've produced, we're suggesting metadata that will actually be able to answer a lot of those questions. How we, this little slide is just to let you, to indicate that we were just looking at some sort of value proposition in the metadata. We understand that historically a lot of this metadata doesn't exist, and we're also looking at the cost of actually finding this metadata and collecting this metadata when you're doing your monitoring programs or doing your sampling programs. So it was a bit of a value that, yeah, you can keep adding metadata to it, you can keep collecting more and more information, but the value of does that actually make the data that you're collecting more valuable? We get to a stage where, well, not a lot more. So we've tried to use that principle to look at just collecting the information that makes the data, that gives the biggest advantage to the data itself. How it's set up. So there's connectivity, and this entity diagram gives some sort of indication of how the different parts of the metadata form together to create proper information about the final data. So for the Northern Territory, I'm assuming, and being a Queenslander, I hope my assumption's not too incorrect, that groundwater is a major source of water supply in Northern Territory, as it is in Western Queensland. And so we've really focused on some of the groundwater metadata. Some of this metadata we've got is not we've got levels. So there's mandatory metadata, and then there's what's the other one? Conditional, and then optional. So there is metadata there that we say you must have, and in this case, groundwater level is a must-have, would be a must-have, because without understanding the condition of the water table that you're in, then how do you make assumptions on what the water quality is at that particular point in time? All right, so the word interoperability, well, when I started this program, I didn't know that the word interoperability existed, but it's certainly something that data people seem to be throwing around now immensely. Basically, all it means is that can it be used by other people? Can the data you're collecting be used by other people for other purposes in the future and at the present time? Does it value add? So this is an idea of again, value adding to the data. You might be spending $1 million collecting data in a water quality program. The value of that becomes greater the more officers can use it, and the more organisations can use it. So just as a bit of an example of where I come from, and I think this is a pretty, this is the water I deal with. Well, no, it's not. That's the end game of the water. The water I deal with is very murky. So when in about mid-2000 we were setting up the event monitoring program for all the Great Barrier Reef catchments in Queensland, and part of my role was to sit down and pour through all the data that had been collected by all sorts of organisations, by the government in their monitoring programs, by local councils, by community groups, everything. We just brought everything in. And we just sort of went, and that was to try and find hotspots, because we didn't have a lot of money. We only started with about $300,000 to do all of the catchments, in the 10 major catchments in the Great Barrier Reef. So we had to be pretty smart on exactly where we started and which parts were more at risk. And so we mined all that data, brought it all in and started looking through it and coming up with some sort of idea of its usefulness. And this is what we found. Out of that data, 5% had no sampling date. We didn't even know when the sample was taken. 15% had no storage or information about how the sample was stored or taken. 15% had was just a total nitrogen figure. We didn't know how it was analysed, what it meant, what was going on. 25% had no sampling method. So we didn't know whether it was a grab sample or, taken from the back of a boat or whatever. And 20%, and the last one was, actually good, actually showed metadata did make, because we could actually say that we didn't know how it was sampled and transported. So in essence, if we, to the nth degree, 80% of the data that was collected over that period of 25 years was not a lot of use to us. And conservatively, and we looked at around about $2 to $3 million went down the drain. Of people, so that's money wasted that people have gone out, resource, time, and knowing from the pauses that I get from people that ask me how much the analysis is going to cost on their samples, it's a lot of analysis too that cost wasted. So this was supposed to be a local example. I did talk to Julia Short, and I did speak to Julia Fortune, who worked on the event. On the Darwin Harbour water quality guidelines, and I just to try and get a bit of an example from here. And she did look through all the historic data, and her point was that yes, there was a paucity of metadata that went along, particularly with the historic data, and she estimated that nearly 50% of the data that she was looking at wasn't of use to them in their to create to create the guidelines. So again, all that effort, all that time, with just a little bit of thought, may have been of use. So I'll hand it back to Linton now, who will talk about the Bureau's point of view in all this.
Thanks, Rob. Well, I've got 2 minutes, so I'll be very brief. But look, from the Bureau's point of view, metadata is really crucial because the water quality information, all the water information we gather is collected by all sorts of different agencies. A lot of it's from state government, territory government agencies, but it's all collected for different purposes and for their particular business purposes. Urban and rural water utilities collect a lot of information, as well as NRM bodies and industry, local government. Altogether, this is really a huge national asset. And under the Water Act, the Commonwealth Water Act, the Bureau has a responsibility to bring all this water information together. So we're gathering information from about 200 different organisations. So you can see that the criticality of having really clear metadata to be able to bring this data together. So we've amassed about 42 million files over that time, in the first 10 years of our existence in this area, and it's growing by about 15,000 files a day. And so we're pushing out a lot more of this information as time goes on. And this can sort of lead to a case where the user of the data is more removed from those who are generating it. And that's where it's really critical to be able to capture and transfer and publish that metadata so it's not misinterpreted. Look, we haven't published a lot of water quality metadata to date, but this is one example of where the Bureau is bringing together information from multiple sources and putting it on a national platform. This is a Groundwater Explorer tool, and this image is showing bores around Australia for which there's some water quality information, including a lot of bores in NT from Denner. So it's updated every 6 to 12 months, and we're looking at updating it monthly. You can click on individual bores and drill down and grab salinity information. But we want to be publishing more and more metadata with this and other water quality services as we're publishing them. The last point I'll make is just around having nationally agreed standards and how that can really accelerate investment in compliant data management systems and instrumentation. So, and that's going to ultimately sort of lower the cost of implementing the guidelines. So when you've got developers of your data management systems, when they've got confidence and they know where the industry wants to go, they can build those systems with more confidence. And there's some of the big vendors like Kistas, Quickham and Aquarius Samples are really trying to implement the guidelines within their systems. So I'll leave you with that. The guidelines are available. I really encourage everyone to get familiar with them and implement them. And thanks for your time, and thanks for inviting us today.
All right, any burning quick question?
Oh.
One.
Paul Wallace from SA Water. That example in the 80% that didn't have all the information you wanted, does that mean that a lot of those samples were analysed by non-accredited labs? Because a lot of the information content we wanted would be the type of content that would be captured, say, in a LIMS.
Yeah, yes and no. Obviously, some of the community stuff would have been analysed over that 25, 50 years at local laboratories, data lost. You know, I'm not saying the data didn't exist, but the data was never captured to a place where you could use it. So that it may be that those laboratories don't even exist anymore. So the issue is that it's about putting the information that laboratories create, that samplers create and all that, and which they may have created, but putting it in a database so that actually people can use it in the future. Does that make sense?
All right, thank you very much.